All right, welcome to Stoichiometry Problems Number 1, Living Answer Key. We're going to go through the problems on, obviously, Stoichiometry Problems Worksheet Number 1. I suggest you pause this program whenever you would like. Try them by yourself, and go along with me at your own pace, making sure, though, that you try these every once in a while on your own. So for the first question, we have to make sure it's balanced, and it already is balanced here for us, which is going to help us. And as we read the question, a couple things we're going to pick up on here that will help us is if we say how many grams of NaOH would be needed to completely react with 29.04 grams of aluminum chloride. Okay. What I do is I usually write up in what I'm doing. I have 29.04 grams of aluminum chloride, and I want to know how many grams of sodium hydroxide I will be able to react with all that aluminum chloride. So in our steps, we said first balance, good. Second, we are going to take our given, which is 29.04 grams, and we're going to turn that into moles. Common mistake is to say, oh look, this is just 1 to 4, so let's just multiply this by 4. You cannot do that because you can only compare in moles. Okay, so if I want to find moles of AlCl3, which is what I'm given, I'm going to have to divide my mass of AlCl3 by the formula weight of AlCl3, and that happens to be, if you take 35 times 3 plus 27, you get 132. When you do that math in your calculator, you get 0.22 moles of AlCl3. I believe that this is good practice to label what you have. You have to have the moles, but to label what you're working with, it will help you in the future. Now, it says, second step we said, is that we need to follow our mole ratio to figure out where our target is. Now, our target is sodium hydroxide. I see that this is a coefficient of 1, so I'm going to write my coefficient for AlCl3 is 1, and I know my coefficient for my target is 4. So if I have a 1 to 4 ratio, that means I need 4 times as much sodium hydroxide as AlCl3. So I'm going to multiply 0.22 times 4, and I get 0.88 moles of sodium hydroxide. Okay. Awesome. Now, the question here, though, said how many grams of sodium hydroxide. If you do a good job of labeling, this will help you make it easier again. I have moles of sodium hydroxide, and I want mass of sodium hydroxide. So I'm going to put it over the formula weight of sodium hydroxide. So if I add 23, 12, 16, and 1, I'm going to get 40. In order to solve this problem, I multiply 40 times 0.88, and I get myself 35.2 grams of sodium hydroxide. When we look at this next part, it says how many grams of NaAlO2 can be obtained from the same amount of AlCl3. So what I'm going to do is I'm going to remove this clutter here. And now instead of knowing how much sodium hydroxide I want to know how much sodium, NaAlO2, we'll just call it, that we need. Okay? So we could either start in the same spot and say I'm going to take my starting, divide it by 132, and get the same number of moles, or you can just start with this if you would like, because we know we have the same amount. Now, I got to look at my ratio. This is a 1 for the AlCl3, and this is a 1 for the NaAlO2, so I'm going to do a 1-to-1 ratio. So that means I do nothing. I keep it exactly the same because it's a 1-to-1 ratio. Now it asks for grams of this, so then I will set this equal to X over the formula weight of my target. NaAl and 2 O's gives me a formula weight of 82. Multiply 0.22 times 82, and we get 18.04 grams. And if you're feeling good, I would say pause the program, then you can keep watching here. We're going to have the same starting amount, and now it just wants to know, well, how many grams of salt can we make? So now we'll go into here. See if you can't pause the program and figure that one out. All right, I see that my AlCl3 is a 1, 2, and I see the coefficient in front of my salt is a 3. So I'm going to multiply my 0.22 times 3. So I get 0.66 moles of my salt. If I want mass of my salt, then I am going to multiply it times the formula weight of my salt, which happens to be 58. Multiply those two together, and you get 38.28 grams of sodium chloride. Again, if you're feeling good, pause it and try the next one. All right, I'm gonna scroll this out of what we're seeing. So I want to check our ratio here. If I want to find water, this is a 1:2 ratio. So keep that in mind. You can see at the top of your paper, I'm starting with the same amount again, with the coefficient in front of my AlCl3 is 1, and in front of my water, where I'm trying to go, is a 2. So I'm going to double my moles to get me moles of water. Moles of water is equal to mass of water over the formulated water, which you probably have memorized by now, which is 18. If you multiply that together, you get 7.92 grams of water. Wonderful. So we'll go to the second question. You will notice that I wrote the word balance very large at the top here, because you got to make sure you balance every equation that you come into contact with here. Okay. So let's go ahead. Why don't you pause and see if you can balance this. All right, hopefully you balance this with a 4, 1, 2. And now let's read the problem. It says, how many grams of sodium metal, so this is my question, are needed to prepare 18.6 grams of my sodium oxide? This one tends to be a little bit tricky, so if you want to pause and try, why don't I give you, this would be the answer. If you don't get that, let's see why. All right. So I'm going to take my given, which is sodium oxide, and I'm going to get moles of that. So I want the mass of that, which is 18.6. Over the formula weight of 23, 23, and 16 are going to give me 62. Then I am going to divide that, and hopefully you get 0.3 moles. Now, this is where people usually make a mistake. I am at sodium oxide, which has a coefficient of 2, and I am traveling to my target, which is Na, which has a coefficient of 4. Okay, so I need twice as much sodium as I do sodium oxide. I need twice as much. So what I'm going to do is I'm going to take my moles here, and I'm going to multiply it by 2. When I do that, I get 0.6 moles of sodium. Again, if I have moles of sodium and I want mass of sodium, I'm going to put it over the formula weight of sodium. When you multiply that together, you should get that 13.8 grams of sodium. Awesome. Question number 3. I would take a moment and I would balance it. Awesome. Question number 3, we're looking at 2 and 2 to balance. I'm going to read the question here. It says, how many grams of Kf, question mark, are required in order to react completely with 132 grams of calcium chloride? So again, calcium chloride is my target. That is what I need to find moles of before I can move along. And no, I can't just double this, because we cannot move along in grams. We can only move along in moles. So what we're going to do is we're going to say if I want moles of calcium chloride, I'm going to take my mass of calcium chloride over the formula weight of my calcium chloride. You should get 1.2 moles of calcium chloride. Check your ratio. Pause when you would like. My coefficient in front of my calcium is a 1. The coefficient in front of my target is a 2. So I'm doing a 1:2 ratio. I'm going to double my moles here. Now I have moles of potassium fluoride, which is what you see here. Wonderful. Now it wants grams of potassium fluoride. So I'm going to say X over the formula weight of 1 potassium and 1 fluorine. Multiply that together, and you get 139.2 grams of potassium fluoride. I suggest you pause the program and try to do number 4. All right, number 4, to balance. We're going to go 4, 3, 2. Reading the problem. How many grams of Al2O3, question mark here, can be prepared from 32.4 grams of my aluminum metal. You first find your moles of aluminum. Then I need to divide it by the formula weight of 1 aluminum. Remember, coefficients do not affect formula weight. So it's still 27 for every single aluminum, has a formula weight of 27. When you do that, you get 1.2 moles of aluminum. Let's figure out where we are and where we're going to go. I have aluminum here, has a coefficient of 4. Where I'm going has a coefficient of 2. So this is a 4 to 2. I am getting smaller. I need half as much. So I'm going to take this number and divide it. Now I'm in moles of aluminum oxide. It would like mass of aluminum oxide though, so I'm going to set this up. Moles equal mass over formula weight of aluminum oxide. Multiply that together, and you get 61.2 grams of aluminum oxide. All right, let's have you move on to number 5, see if you can balance and answer A and B. B has an interesting formula weight. I hope you don't make a mistake on that. Pause the program and come back when you're ready to check. All right, so we'll start by balancing. When we balance, we have a 2 and a 2. Let me pop my number up here. Sorry, how many grams of copper, so this question I want to go here, how many grams of copper will be produced from my 96 grams of copper oxide? Well, I have to take what I know and put it into moles. 96 divided by the formula weight of my copper oxide. Okay, so 1 copper and 1 oxygen. That's where the 80 came from. Divide that and you get 1.2 moles of copper oxide. Now, let's talk about our mole ratio. We go from here, the 2 to 2 is also, God bless me, the same as 1 to 1. Okay, so I'm going to leave that number alone. So I also have 1.2 moles of copper. That's what I'm going to make. It wants to know grams of copper. So I'm going to go ahead and use moles equal mass over formula weight of copper. Now we're going to use the same amount, so we could just start with this number if we wanted, or you could divide it by 80 again and get the same amount. But now this question is saying how many grams of oxygen will be formed. Let's get rid of some of this clutter up here, and we're going to say my coefficient ratio, we're going from 2 on this side to 1 on that side. So I'm going to end up dividing that in half, which gives me 0.6 moles of O2. Now I'm going to do moles equal mass over formula weight. Which formula weight do you think you should put here? Sometimes students put a 16. However, if we want oxygen gas, remember they're diatomic. They always come in a set of 2 stuck together. So if I put them on their little scale, they would not be 16 in their formula weight, they would be 32. Multiply these two numbers together, and you get 19.2 grams. Next question, number 6. What mass of chlorine, so I'm going to put my thing here, is needed to react completely with 86 grams of Ki? Got to make sure we balance it here before we go too much further. 2 chlorines, I need a 2 for my chlorines. 2 potassiums, I need 2 for my potassiums. And then I have 2 iodines and I'm good to go. I've been given potassium iodide. I'm going to take 86 grams of my potassium iodide and turn it into moles of potassium iodide. So I'm going to add a potassium and an iodine, which will give me 166 as my formula weight. Divide that out. I'm going to get 0.52 moles of potassium iodide. Now I'm going to worry about my mole ratio. I'm starting here at my potassium iodide. The coefficient is 2. My question is taking me back here to chlorine. People do not like to go backwards, but so this is a 2 to 1 ratio. 2 to 1. I'm going backwards, 2 to 1. So I'm going to divide my moles in half. When I do that, I get 0.26 moles of chlorine. And again, just like my oxygen, it is Cl2. They come in a pair. So moles equal mass over formula weight of 70. Multiply it together and you should get 18.2 grams. Number 7. Let's have you try to start. Whoops, those are the answers. Pause this. All right. So for number 7, it has 3 parts. And again, we're going to start with the same amount of each of our sodium sulfate. So we're going to start with 188 grams of sodium sulfate. And again, our life cannot begin until we balance this equation. I see 1Ba, 1Ba, 2 Cls. Oh no, I need a 2 over here for my 2 Cls, 2 Nas. Now I have 2 Nas, 1 S, 1 S, 4 Os, 4 Os. We are balanced. I would like to try this one a little bit differently here. How about if you pause the program? Now, did you get 273.24 grams? Let's go back and see how we did that. First, I need to take what I have and I need to put it into moles. So I'm going to find moles of my sodium sulfate, and I'm going to take my 188 and put it over the formula weight of 2 sodiums, 1 sulfur, and 4 oxygens, which is 142. I'm going to divide that, and I'm going to get 1.32 moles of my sodium sulfate. Now, this question says, how many grams of BaCl2, so I'm going to go from here to there, will react. I have a coefficient ratio of 1 to 1, so I also have 1.32 moles of BaCl2. Moles equal mass over the formula weight of 1 barium and 2 chlorines, which would be 207. Multiply these two numbers together, and you should get 273. Let's give you the answer here on this one again. Let's see, can you get 153.12? How should that happen? We're going to take the exact same number of moles here because we are using the same amount. We're saying we still have 188 grams of sodium sulfate. Now I want to know how many grams of salt. So I'm going from my sodium sulfate out to my salt. So I have a 1 to 2 ratio. So with this number, I'm going to double it to 2.64 moles of salt. Moles equal mass over the formula weight of 1 sodium and 1 chlorine gives me 58. Good. Last but not least, how many grams of barium sulfate? So we're going to do this last one. Hopefully you get 307.56 grams. We are going from sodium sulfate to barium sulfate. We start with the same amount. We have my 1.32 moles. That is a 1 to 1 ratio. So I have the same amount of barium sulfate. Moles equal mass over the formula weight of a barium sulfate is 233. Multiplied by 1.32 gets you your 307.56. All right, let's talk about these thinkers. Some people say these are easier, some people say these are harder. I'm just breaking you out of the mold that you have kind of been doing over and over again. So let's talk. It is balanced. How many moles of H2, question here, would be needed to react with 2.4 moles of O2? Now, I want to try to answer that question. Pause the program. The only tricky thing I'm trying to do here is you do not have to divide, you don't have to do anything, you're already in moles, you're on a mole to mole ratio. So this is a 1 to 2, 1 to 2, so go ahead and double that. And then how many moles of O2 would be needed to react with 0.32 moles of my H2? Okay, this is a 2 to 1, 2 to 1, and I don't have to go any further, just have to divide it in half. Beautiful. So trying to get you don't need a formula weight. If it's just asking moles, then just ask moles. Okay. How about number 9? Which one has more molecules? The only thing I wanted to get you to think about this is that moles are how we count molecules, right? It's 6.02 times, I said that wrong, 6.02 times 10 to the 23rd of anything. Kind of like a dozen is 12. 1 mole has that many. So if I can figure out which one has more moles, I will know which one has more molecules. So the main idea here is to convert both into moles, because moles tell us how many molecules we have. So how many molecules are in 85 grams of potassium chloride? Well, if I want moles of potassium chloride, I put my mass of potassium chloride over the formulate of potassium chloride, and I get 1.15 moles of potassium chloride. If I would like to know my grams, or my moles of salt that I would have if I had 85 grams of salt, moles of NaCl equal mass of NaCl over formulate of NaCl, which happens to be 1.47 moles. So the winner, obviously, here, we have more moles of salt in that sample, so therefore we have more molecules.